notice a number of you are talking about the quiz questions, which is a very good thing. Chris is going around checking the homework. There are the correct answers to the quiz. I don't know if it's just, look, excuse me. The last couple of mornings, I've been a little late getting in, and I'm like never late. Today I had to bring stuff for a mathletes meet and so on and so forth. But it's just been tough to get up and get going and get moving and get things going. And I don't know if that's reflecting itself in careless mistakes on your quizzes or not. But you guys are making some mistakes that are sloppy. For instance, on one paper I saw that -4 divided by -4 was -1. A number of people on number 2 came out with the signs reversed. They came out with n+7 times n-2.
Yes.
So I think that we need to be a little sharper, a little more careful about the kinds of mistakes that we're making.
Because he didn't check homework.
Are there any questions you want to go over on the quiz? Anything I need to go over and highlight and so on and so forth? Brian?
What's the difference from like putting like n minus for like number 2?
Did you do a quick mental check?
Yes.
And if you do, you get plus 5n, right? What did the question ask for? There's your difference, okay? Generally speaking, until we get into, well, we did Plan B yesterday. In Plan B type, this isn't true, but at all other times it's true. See this middle sign? That will always be the sign of the bigger number. So that's a good general rule to go by until you get to Plan B. Plan B, throw everything out the window. Okay. Any other questions? Okay. So let's get going on today's do it. And you'll notice that in the directions, they say to factor each by factoring out the greatest common factor. So they're telling you how to do it, which is a very good thing. Okay? Spencer? Okay. So, the first one, what is the greatest common factor? Everybody.
5A.
5A, good. So that's 5A times 2B plus 1. Now, yesterday on the homework answers, you guys didn't catch me. I got one wrong. And I didn't do a quick mental check. Had I done it, I would have caught myself. 5A times 2B is 10AB. 5A times 1 is 5A. So that is the correct answer. Number 2. Now, this is getting a little tricky because there's lots of letters and there's lots of exponents and there's different coefficients. Let's break it down piece by piece. Numerically, what is the greatest common factor of the coefficients? Good. 3, good. Now, how many G's do they all share in common? AJ?
0.
That's right, none, because the last term doesn't have a G. How many H's? Everybody? No, how many H's do they share in common? Well, one. Good. So that leaves me with, when I pull out or factor out the 3 from 3G cubed H, I'm left with G squared, because the H also came out. Minus 3. Oh, this is G cubed, I'm sorry. Minus 3G squared, the H comes out, plus 4. Now, as you can tell, there was some hesitation in my voice, and I think I at first screwed up the first one. So it becomes extra imperative that I double check by doing a quick mental check on the way back. 3H times G to the third is 3GH cubed. 3G times negative 3H times negative 3G squared is negative 9G squared H. And 3H times 4 is 12H. So I know that that is correct. Likewise, I look at the net. Go ahead.
Do we have to like keep going with that?
Keep going.
I mean, like keep.
Oh, you want to factor this? The problem is it's cubed. If this said G squared minus 3G minus 4, yeah, then you would factor
So
completely.
we only factor more when there's a squared in the front?
The answer is when it's factorable. And you haven't learned anything about factoring cubes yet. And factoring cubes is beyond the scope of this year. That's one of the things you do in 11th grade. That's one of the 2 variations that are a little different than this. Okay? Other than that, you're learning all of 11th grade factoring now. All right, next up. They share a 3 in common. They do not all have x's. And they share a y cubed in common. So I'm going to go with 2x squared, the y cubed came out, plus 3x. 3 of those y's came out, so there's 1 left, plus 6, and then it's y squared. Now let's multiply back and make sure it works. 3y cubed times 2x squared is 6, x squared y cubed, that works. 3y cubed times 3xy is 9x, y to the 4th, that works. And 3y cubed times 6y squared is 18, y to the 5th, that works as well. Okay, any questions? Now, if you can factor common factors, the first one's very easy. I think every person in the room should be able to do it practically in their sleep. The next two are much more challenging. If you can get the next two right, you can do pretty much anything we will ever ask you with a common factor. All right, any other questions? All right, so now we get into the next part of today's work, which is to factor each of these. And I'm going to use the AM method. Got to multiply out to negative 24 and add up to 10. It might be very tempting right now to think 6 and 4. Bless you. But if I want to get negative 24, the 6 and the 4 have to be opposite signs. And if they're opposite signs, there's no way you'll get 10 out of the deal. So the correct answer is x plus 12, x minus 2. Question?
Oh, no, I want to explain it too.
All right, we'll get to that in a second, but let me first do the quick mental check here. It's very important. All right, ready? X times x is x squared. X times negative 2 is negative 2x's. 12 times x is 12x's. Negative 2x's and 12x's add up to 10x's. 12 times negative 2 is negative 24. Now, up until now, everything we've done has fit in a very traditional kind of factoring. And then we started to learn about Plan B. I want to skip forward to C before I go back to B. When we go to Plan B, what we do is, like in the first three, we always look for a common factor. Is there a common factor? No. So we have to go for Plan B. I think earlier in the year I did this thing where I wrestled the kid in class a little bit, and I showed that based on what that kid did, my strategy changed. I love to trap what we call a cross wrist. I trap it across, I pin it to the kid's body, and I wait to see how does he react with his arm on the other side. Early in the year, kids don't know much about wrestling, and they'll try to do a push-up. They'll reach their arm out to the side. That's death. If you do that, the guy's gonna throw a half in, and you're gonna get pounded, okay? The second possibility that they'll do is they'll try to reach forward. That's not good either, because you're gonna get cross-faced. Then they'll learn and they'll start to bring it back here. Well, that's not good because you're gonna get barred. And then, if you don't do any of those three things, and maybe you put it here where you think the guy can't do anything, then he's gonna spin out to the side and he's gonna try to trap the cross wrist through your crotch. And then if he does that, he's gonna start working claws and back hook tilts, he's gonna start working cradles. He's got all these different things he can do to you. So, based on what you see from your opponent, that determines what it is that you're going to do. In fact, that's what medical testing is all about. What they do is they say, I'm gonna test for this. If it's there, then that's the disease. And then if that's not there, then I'm gonna test for this, and then maybe it's the other disease. There used to be a show on TV called House. I don't know if any of you ever saw it. But with House, that's what they constantly did. They constantly said, well, let's take a guess at what this disease is. And then they would test for that disease, and if it wasn't it, he would go to another one. And inevitably, in most of the episodes, he had to come up with some test where he would kill the guy if he was wrong. So then he would try to figure out what the right guess is. So when I look at this, I say to myself, okay, option one, let's look for that common factor because of the 2 in front. But I don't have a common factor. When I don't, I go to Plan B. I multiply by 2 here, and I get x squared plus 7x plus 6. Then I just factor that as normal. X plus 6, x plus 1. Now, Spencer said one of my most erudite things that I have heard any students say in class in all of my years of teaching yesterday.
There's a typo in this?
No, that I hear all the time. Spencer turned around and said, but you just changed the question. You can't do that. And when I teach this lesson, up until yesterday with Spencer, I always say, if I was a kid sitting in class, I would raise my hand and go, what's up with this? You just changed the question. Can I do that when I take my test and I don't like a question? I'll just change it to something I do like. And then I will get really, really high grades with a minimal amount of work. This is a lovely system you've created, Mr. Lindquist. It sounds like politics. Unfortunately, no, you cannot just do that. But in mathematics, there is this brilliant principle that says if you take whatever you're starting with and you do an operation to it and then you invert or do the reverse operation, you get back what you started with. And there are many times in proof theory or in solving problems that can become an advantage. Now, not 100% exactly that, but very similar to that. When I multiplied the last term by 2, I created an avenue that let me see a solution. But I can't just leave it like that. If I go to plan B and I multiply by 2, like I did here, I then have to come back in and divide by 2. And that balances out the fact that I multiplied the 2 at the end there. Okay? Now that's not a completely perfect explanation, but it's a pretty good one and we can work with it. Now, 6 divided by 2 is 3. So the first factor is x plus 3. And when you cannot reduce the fraction, you then do the elementary school trick and multiply the 2 in front with the x, so you get 2x plus 1. And those are the factors, x plus 3 times 2x plus 1. Of course, the order can change by the commutative property. It is extremely important, unbelievably important, that you do not immediately go to plan B. In fact, the essence of the name plan B is that it's the second option. If you attempt to do plan B when there is a common factor, when you get done with the problem, you will not show one of the factors. It dissolves one of the factors away. It's acceptable for solving equations, which we're going to get to soon, but it's not acceptable for factoring. So you must look for the common factor first, which is plan A, and then only when there's no common factor present, and plan A does not work, we then go to plan B, the essence of the name. Any questions so far? Okay, Professor Dominici, explain B.
Okay, so basically, like, you see that there's a negative 9 and an x squared, but apparently you couldn't see a normal x.
A normal x.
Now, that x is there, but the thing is, it's 0x, so you gotta
Stop
find-
right there. He has a perfect explanation so far. What he's doing is he's saying in the middle is really 0 x's. Okay, we don't bother writing them because 0 times x is just 0, so there's really nothing there. But there really truly is, if we look a little deeper, 0x. Okay.
So basically what you gotta do next is to find the greatest common factor of the greatest common factor of negative 9, and that would be 3 and negative 3. So you would do x minus 3, and then x plus 3.
The only thing I object to is the use of the term greatest common factor, because that suggests it also goes into x.
Oh.
Let's say square root.
Square roots.
That's right.
Yes, square roots.
All right, what Anthony's saying is this. The answer is x plus 3, x minus 3.
Because 3 minus 3 is 0.
Right, watch. Let's do a quick mental check back. Ready? X times x is? X squared. X times negative 3 is? And then positive 3 times x is? Positive 3x is. What does negative 3x and positive 3x add up to? 0 x's. So that's why the term's not there. And then 3 times negative 3 is negative 9. Now, can everybody see that the only time this will ever happen with the 0 x's is when these two numbers are the same? That's the only time. So we actually have a special name for this case. Even though it's the same exact thing, you just have to realize there's 0x there. We have a special name that shortcuts it a little bit. And we call it the difference of two perfect squares. Difference means to subtract, that's what's in the middle there. Two perfect squares. See, I can square root x squared and I can square root 9. What do you think this would be? What would that one work out to be? AJ?
X plus 5 times x minus 5.
That's right. As soon as, again, this is just like the wrestling situation where I'm looking to see what's the reaction, and then I adjust accordingly. As soon as I see there's 0 x's in the middle, I realize that it has to be the same number here and here, because that's the only way to get 0 x's. I also realize it has to be opposite signs, because if the signs were the same, it wouldn't add up to 0. So then I square root x squared, that's x and x. I square root 25, it's 5, and negative 5. Yes?
Would you ever give us a question that at the end there's not a perfect square?
Well, then you would say it's unfactorable,
Okay.
in a situation like this with a difference. Let's try this one, ready? X squared minus 100. Lena, instead of working on the homework, let's work on this, right? We're supposed to be following the lesson so we understand. Okay, Spencer, what do you think?
X plus 10 times x minus 10.
Yes. If somebody's gonna get this wrong, what do you think they're gonna write as their answer? They're gonna write x plus 50, x minus 50. So rather than square root the 100, they'll half the 100. But the problem with that is then 50 times 50 would be 2,500. It wouldn't be 100, okay? So just be careful about that. And one last try. I think it'll be the last one. 4x squared minus 81. X squared minus 81. Janelle, what do you think?
I took my hand back down.
Oh! Anybody else? AJ and Spencer have already spoken. Anthony, you think you got it? You're like Janelle, I put my hand back down. It's really not hard. Let's go back to here. Remember when I said you square root each of them? Right?
Oh, I think.
Oh, now we got some hands popping
I
up.
have it.
Janelle, now that your hand has exploded back up again, we'll give you a try.
I don't know if the format is right, but 2 times, x, wait.
Well, let's put things this way. Does everybody easily agree it's gonna be plus 9 and minus 9 at the end?
Yes.
Right? All right, so now what's the square root of 4x squared?
2.
2x.
I got it.
So it's 2x plus 9 and 2x minus 9. Okay? Any questions? Okay. With that in mind, let's do these 4 difference of 2 perfect squares factorings. Go ahead.
Put a negative square. Put a negative sign.
Sure. Think it through. I'm so excited. I just can't hold it. All right, what do we get for the first one here? T minus 5, T plus 5. Very good. Next one.
2x plus 3.
Ah, sweet, the sound of learning. Next.
4h minus
Up. Always look for a common factor first.
There's no H in the second.
There's a 4. And that would be 4h squared minus 9k squared. So that would be 4 times 2h plus 3k
Oh, now that I can get right.
times 2h minus 3k. You have to look for the common factor first. They share a 4 in common. Otherwise, you may have had the answer 4h plus 6k, 4h minus 6k. But the 4h plus 6k and the 4h minus 6k are both further factorable. In other words, they could have had a 2 pulled out from each of them. And then in the end, the 2 times 2 would be 4.
Wait,
So always pull out the common factor first.
what if you multiply the h by the k? Wouldn't you get 6hk? And that's what it was.
Yeah, but then you would get negative 6hk, they wipe each other out.
Okay.
Now, 4 minus b squared.
2 minus b.
Don't let it bug you. 2 plus b, 2 minus b. We just reverse the order. Okay? Still adds up to 0 b's in the middle, right? 2 times negative 2b is negative 2 b's, 2 times b is positive 2 b's, so I still get 0 in the middle. Yes?
I put negative b plus 2 and then b plus 2, that's still.
It would be acceptable, but keep going with the order this way, it's a little cleaner. All right, any other questions? All right, so yesterday we spoke about how my middle name was Robert Carl, which apparently fascinated, or my middle name I should say was Carl. And apparently the fact that my middle name was Carl fascinated quite a few of you, as at lunch yesterday I heard about it quite a bit. Now, the whole point behind that story yesterday was to mention that when I was growing up, if my dad used the term, or the moniker, Robert Carl Lindquist Jr., I needed to pay attention. I needed to lock in on whatever my dad was saying, or the beatings were about to begin, right? Dad was not the kind of guy that sat around and said, son, how do you feel about this? My dad could not have cared less how I felt about anything. My dad was absolutely going to make sure that you did what you were supposed to do. And God bless him for it, because that is the right way to be a father. We're not here to be best friends with our children. That comes later in life. Early in life, just do what you're told, because dad knows better than you do. In fact, many, many years ago, your parents probably remember this, maybe your grandparents. Your grandparents definitely remember this. There used to be a TV show called Father Knows Best. So, and I also think Mother Knows Best, just so I'm not accused of misogyny. But I do want it clearly understood that we learn from our parents and they tell us what to do. Now, one of the things that I notice with this is the phrase factor, and specifically completely. Just like when my dad would say Robert Carl Lindquist Jr., in my mind, that translated to pay attention or pain follows. When I see factor completely, you need to do something, or wrong follows. Completely always means 2 steps. What does factoring completely mean? 2 steps. Write that on your paper. Factoring completely always means 2 steps. Technically, it could mean more than 2, but we really don't see more than 2 at this level. A really good example of that would be number 2, akin to what we were just doing. Is there a common factor in number 2, yes or no? Yes, what is it? 4. 2 is a common factor, but it's not the greatest one. So it's 4 times x squared minus 9. Now, factor x squared minus 9.
4 times x minus 3, x plus 3.
That's right. Now, let's just go off to the side and pretend we did not look for a common factor. Let's show you why it's wrong. That would be 2x plus 6, 2x minus 6. And you might think that you factored it completely, but you have not. Because don't the first one share 2 in common? So that's 2 times x plus 3. And doesn't the second one share a 2 in common? So that's 2 times x minus 3. And now what is 2 times 2? 4. So that's where the 4, x minus 3, x plus 3 comes from. So the easier way, by far, to do this is to always first look for the greatest common factor, get that out of there, and then look to factor it, okay? Try numbers 1 and 3. One and 3. God bless. Okay, is there a greatest common factor in number 1?
Yes.
Yes, what is it?
3.
Good, so I pull out that 3, and that leaves me with n squared minus 2n minus 3. Then I factor the trinomial. What does that factor to?
N minus.
What is this, how slow we can speak today?
That's as far as I got.
How does n minus 3n plus 1 sound?
That might be it. That's possible.
That's what I got.
Right? Oh, it's right. What?
Why would you do plus one?
Because negative 3 times positive 1 is negative 3. If I put a minus 1 there, it would have come out to positive 3. Okay, next one. Is there a common factor? Bless you. Is there, yes or no?
Yes.
So I get 7 times x squared minus 1. Now, factor x squared minus 1.
It's a 7. Oh, it's a 1. Oh man, I didn't divide that.
Factor x squared minus 1, what do we get?
Uh,
Come on. It's a difference of 2 perfect squares. What does it have to be?
X plus 1,
X plus 1, x minus 1. Good. Now let's have a little fun. Fun, fun, fun. The only thing this could possibly be is the difference of 2 perfect squares because there's no common factor. X squared minus y squared, x squared plus y squared. Am I done?
No.
No.
Wrong.
Because I can still factor x squared minus y squared. This is going to be x plus y, x minus y, and then x squared plus y squared. And that's about as tricky as it gets, guys. Hasta la vista, vaya con Dios, toodaloo, ta-ta, arrivederci, smile a lot, ciao, arrivederci, adios amigos y amigas, cheerio, salut, salut, office, sayonara.
No game, yeah.
One pair of shoes plus 1 shoe. And then I still can't find my other shoe. Gotta draw another pair from home.
Jeffrey Tejada.
So let's go to break. Let's go. God bless
Money was found and turned into the main office. If you lost cash, please come to the office. Good morning. Today is Tuesday. Tuesday, January 10th, 2017. It is an 8A. This is Jeffrey Tejada with your morning announcements. Please stand for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Please be seated. For all National Junior Honor Society members, this Wednesday, January 11th at 2:45, there will be a meeting in the library. All must attend. See Miss Bing if you have any comments. The girls' volleyball team lost an exciting 5-game match to Ron Company yesterday. Paulina Rakowski played great in the middle, adding key blocks and kills. Sabrina Guarino added a solo sub block with her brought het teammates to their feet. Lainey Bobble and Hannah Falvey hustled throughout the match, setting up their hitters. Caitlin Krupa turned it on in the 5th game, but unfortunately it was not enough, and the team lost 23-25. Our next home game is Wednesday versus Oregon.
Boys, don't talk.
And happy birthday to Jonathan Garcia. Thank you very much, and have an amazing day.
How's everybody?
Good.
Nice.
Maybe.
I mean, maybe. Oh, well. Okay. Thought I had some. All right. All right, why are we talking? Thank you so much for settling down. Boys, Christian, head in the game. Now, you have some relearn packets that you're supposed to be working on. Okay. Let's get started on those. Caitlin apparently did a nice job trying to pull that team back from the brink of defeat. It didn't quite work out. Huh? No, but I just listened to the announcements.
For the last game, the 5th game, we were like in a tie, so like that was a tiebreaker. And Paulina served the ball, and it was 24-24, and they had to get to 25 points to win overall. and she served the ball, and then it went to the other side, but they tipped it right back really quick, and the middle wasn't paying attention. She was looking at me and Paulina.
No,
So
no,
the ball-
don't go putting a teammate down. Don't, people make mistakes. Have you ever not paid attention during something and made a mistake?
Sure.
All of us have been there, done that. So, okay, now, whatchamacallit? You have your relearn packets, get started on those, bring up any questions that you have. We'll go over them and we will get started.